Alright, well, I am back. We're going to get started back doing this camera velocity work. Alright, so let's turn off parts of our camera that we're not using. Let's turn off the zoom, the direction, and turn on the lead. So let's see, what is busted with this? I mean, it's looking pretty good. Alright, so what is it not doing? It is not... Zero files to check out. Well, thanks for telling me that, Unreal. So let's get our player proxy actor stuff set up. What is not happening is we're not returning to 0 and we don't have smoothing stuff. So let's get our return to 0 when the velocity is all over the place. Let's make sure to check out these files. Alright, so it's like determine camera lead. So basically what we want to happen is if your velocity is all over the place, like we can't actually acquire a lead target, then we need to return you back to 0. So we need like a float here, which is like M, no target, no lead target, found time. Alright, so if m acquired target equals true, then we're gonna set this game time. And we probably need this wobble stuff going on here. Alright, so lead acceleration is something that we're going to have here. So basically if now minus the no lead target found is greater than, I guess, m camera data, camera lead, reset to origin time, then basically what we're going to do is we're going to say like we're resetting to the origin. Alright, so yeah, it's like if not acquired target and this. Alright, so let's get this reset lead to origin. Let's set that to false. And let's go to our data structures here. This is Dashkin game data.h. And .cpp. Alright, this is the delay for velocity change reset to origin. We'll have that default at 1. So let's see, what exactly are we trying to accomplish here? Alright, so we want f vector, we want our destination. So if m acquired lead target, then our destination equals this current camera lead offset, or it's the lead end position. So else if reset lead to origin, then the destination is going to be this f vector 0 vector. I guess it's just kind of else. Well, I guess otherwise there's nothing. Like, it's not supposed to move. So it's basically if acquired lead target or m reset lead to origin, then we're actually going to do stuff, is what it looks like. So I think it looks like this. Basically, we set our destination to 0 vector, and if we actually have a lead target, we're going to try to go there. Otherwise, we're going towards the origin. Alright, well, we'll see how it works. And what this should hopefully do is it's going to kind of snap around and look pretty not good. But once we get it kind of moving where we want it, we can then mess with it so that it at least moves where we want it. Then we can start smoothing it off, making it so it arrives at destinations and stuff like that. Wow, that is all sorts of screwed up. So let's take a look at what this thing looks like. So what does this actually do then? If we're running to the right, let's just get a simple log of running to the right. Alright, so we were running to the left, one camera lead turned into -25. Well, this shouldn't be lead in position minus destination. It should be destination minus current camera offset. It's like, yeah, something's messed up here with that. What in the hell? Alright, so we've acquired target. So the question is, why exactly are we losing our target? We're not losing our target, so how? Acquired lead target should be true, so like we should never come in here. So like we're acquiring our lead target, and then we're immediately losing it? Because our wanted camera lead is 0.10? And what is that lead time for the camera? One second? So we shouldn't lose our target unless there's some other thing, like... It's like the camera lead, offset delay, camera lead. I guess maybe this needs to be much larger, like 5 seconds. And then our camera lead. return to origin time should be also like 5 seconds. What the fuck? Ah. So our conditions here are wrong for acquiring a target. Basically, we want to reset our position every single time here. Alright, so basically this would be like, okay, if the size is, if we move out of it, then we're gonna acquire a new thing. So what was happening basically is, as this thing moves, it's counting up wrong. Basically, we have our timer going for if our velocity is trying to put us in the same spot on the screen. This algorithm just sucks. It's not very good. I mean, fundamentally, it's just not working properly. Like, there's so many weird edge cases. I mean, maybe we have to rethink how exactly we're supposed to calculate this thing. I mean, you wouldn't think it'd be that incredibly difficult, right? Like, lead the target nicely. The problem is we're moving all the hell around, and we don't want the camera to do anything insane. I mean, maybe we should just make it simple, right? Like, instead of having some sort of lead dynamic that's crazy, it's just like a quadrant lead. Like, we can lead in 8 directions. So the camera has kind of like a velocity box sort of thing on it. Well, I'm trying to think. I'm not really finding a good solution for this, the camera lead. Like, because the player is going a certain direction. I mean, if you're just running to the right, I mean, that's super easy. Just, you know, track where he is and lead. But the problem is, if you stop running, we don't want the camera to be all crazy town on you. Because I'm trying to think. I mean, it may just be that we want the zoom, and that's it. Like, the zoom is the actual correct solution to it, and not the lead. Maybe we just shouldn't have leading in here at all. We should just zoom out the camera and do it that way. Because what's going to happen there is you zoom out, so you know your reference points all change equidistantly and nicely, and that's fine. So I don't know. I think, you know, I've been banging my head against the lead stuff, and every single solution I've come up with just hasn't looked good. So I'm just gonna abandon ship on it. Just be like, nope, we're not doing camera lead. So let's just take it the hell out. Like, it's just garbage, and it's not working. So let's just get rid of it. You know, no problem. Let's just delete it. It doesn't work, and we're not finding a good solution, so we'll just do it later if we ever want it and use the tools we have, because I spent way too much time for us to just mess around with this thing. Well, I do think we actually want this camera, the follow velocity. We may want that at some point. So let's just not do it. How about that? So let's just fix all of our compile errors. Yeah, we're just cleaning stuff up. C++ is just a real pain in the butt to get rid of code. It's one of those languages where it's a lot easier to write code than it is to remove it. And it really has to do with just how C++ is structured and how you can't really get good error messages for stuff. Because in a lot of other languages, it's a lot easier to remove things because you can kind of compile it in real time or whatever, give you a bunch of hints, and then nuke stuff. But C++ definitely just not set up to be able to do that. So you end up with a bunch of spaghetti code, and then nobody ever fixes it because it's difficult to do so. Or maybe I should be specific. I end up with a bunch of crappy code, and then I don't fix it because it's difficult for me to do so. So let's just look at the camera that we got right now then. Like, if we're not going to do camera lead, then fine. Alright, so what does it look like? We're running. Seems like what we want is the camera follow. Well, we want dynamic zoom on. Yeah, it could be just as simple as having a camera direction work kind of like this instead. So yeah, this really seems like maybe it's an issue with the camera. Like, I mean, I guess that's just fine. Like, we could lead a little bit more or something. Like, we could zoom out more, and that might help. Yeah, I think that's better than it was. The other thing would be to try to keep the camera outside of these collision boxes. So if we were like up against a wall here, the camera would actually get stuck. It wouldn't be able to penetrate the wall. I mean, it's not awful, it's not bad, it's just, I can imagine it could be better. Look, Gherkin, I'm just messing around. I'm thinking about the camera while running around, and I think the camera's pretty much fine. I mean, the only thing I'm thinking about right now is something that would make it so the camera wouldn't actually move over here, that the camera would stop here. Exactly how that would work. Basically be like the camera can't move up. It can't move into certain areas if there's stuff blocking it, like it would. Like, how would it work? Like, it'd have to cast from the object it's following to where the camera wants to be. So, like, the camera would want to be, like, you know, right here. And it would instead move up. I'd have to have some rules for exactly how it should move. Do we even have the tests for this sort of thing? In our physics utils? We've got like collision channels and hits and all that sorts of stuff. I mean, we'd basically be looking at the terrain only for collisions. So let's see. Is there a collision channel that maybe we could set for only the terrain? Let's go into our settings. Well, I guess we could change like maybe spectator into our camera. So it'd be like, basically we change everything to just the terrain. What we do is we call like sweep sphere in a direction, and we try to move ourselves. And let's just mess around with this and see what we can do. Let's have a radius of, you know, something like 100.0 f. Let's do E, collision, channel, spectator. ECC camera? Is that what we should do? So we got our hits, and then our ignore actor. We'll just do our followed actor. So let's look at what our trace channel for the camera looks like. Yeah, Kirkin, I don't know why I woke up earlier today. You know, I've already been streaming for like 3 hours. I just kind of did. So I was like, well, I'm up, so I might as well start working. Because I don't know when I went to sleep. But it was definitely like, I did not get, I don't know, somehow I am in a much more energetic state than yesterday, even though I got much less sleep. I don't know what's wrong with me.